So the title of this section is just solving basic equations. All of Chapter 1 is going to be involved with solving equations, and we're going to do lots of different styles of equations. And so this first section just gets into linear equations. So the first example asks you to solve the equation, of course. And so the equation we're looking at is 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2. So we want to take a look at how to solve this equation. And you may remember from high school algebra that when you have something like this, you want to see if there's anything you can distribute first. So you notice that that 2 can be distributed, so we get 2x minus 6, and then we still have the minus 17 on that left side. On the right side, we can distribute the negative 3, so we have 13, negative 3x, and then minus 6 there. So now we want to combine any like terms that we have on each side. So I've got a negative 6 and a negative 17, so that gives me 2x minus 23 on the left side. And then on the right side, you've got a 13 and a negative 6. Those can be combined to give you 7 minus 3x. And then you want to get all the terms that have the x's on one side and all the terms that have a constant on the other side. It does not matter which side you move the variables to, so I'm going to move it to the left side just because that's kind of traditional, but it could be the right side, it wouldn't matter. So I'm going to add 3x to both sides, and so we get 5x minus 23 equals 7. And then we want to get that 23 over there with the 7, so I'm going to add 23. So now we have 5x equals 30, and then we're going to divide both sides by 5. So our solution to this equation is x equals 6. Okay, let's take a look at example 2. So example 2 is what we call a rational equation because it's got some fractions in it. So we've got x plus 2 divided by 4 minus x minus 1 divided by 3 equals 2. And there's some different ways that we can solve this. One option that I like to use is what's called clearing the fractions. I'd rather get rid of the fractions if there are any on both sides so that I can just work with it as a basic linear equation. So the way we're going to do that is we're going to look at the denominators that are up there and think about what is the least common multiple between those denominators. So right now we've got a 4 and a 3, and it might help to put this 2 over 1 just to kind of keep everything leveled. So what's the number that both 4 and 3 go into, the least common number? So that would be 12. So let me write that over here. So the least common multiple between these denominators is 12. So now I'm going to multiply everything up there by 12. And I like to go ahead and put that 12 in front of all the terms that are up there. I'm going to rewrite this just to make it look a little bit neater. So we have x plus 2 over 4 minus the x minus 1 over 3 equals 2 over 1. And so I'm going to multiply this first term by 12, the second term by 12, and then the third term by 12. And so when doing that, for the first term, hopefully you notice that the 4 and the 3 will divide, or I'm sorry, the 4 and the 12 will divide out. So 4 goes into 4 once, 4 goes into 12 3 times. So that first term, we have 3 times the x plus 2 that was up there in the numerator. The next term, the 3 goes into 3 once, the 3 goes into 12 4 times. So we have minus 4 times the x minus 1 that was up there. Notice I put parentheses around that x minus 1 and that x plus 2 because that constant's going to have to be distributed. The other side, we just have a 1 in the denominator. Nothing we can do with that. So we need to multiply 2 times 12, which gives us 24. So we're allowed to multiply everything up there by 12. Remember, you can do anything you want to an equation as long as you do it to both sides of the equation. So I'm going to distribute this 3, so we get 3x plus 6. Distribute the 4, we get negative 4x. Negative 4 times negative 1 gives me positive 4, and that equals 24. Now let's combine like terms. So we've got 3x and negative 4x. That'll give me negative 1x. And then 6 and 4, that gives me 10. We want to solve for x, of course, that's our goal. So I'm going to subtract the 10 to the other side. So I have negative x equals 14, and we have to get rid of that negative. Remember, that's kind of like multiplying that x by a negative 1. So if I want to get rid of it, I'm going to divide both sides by negative 1. So then that leaves me with x equals negative 14 as our solution. Okay, so let's take a look at example 3. So we have another rational equation that they're asking us to solve. We've got 1 over x equals 1 over 5 plus 3 divided by 2x. And a couple things I want you to notice about this. We've got denominators, of course, because we have fractions, but we also have variables in the denominator. Notice that 2 of these denominators contain an x, and that wasn't the case in the last example. So you may see some questions in the homework where they ask you to look for the restrictions on they may use the term domain, or they may just say on the variable. In other words, what they're asking you here is what are values that cannot work for x in this example. In other words, the one number you can never divide by, ever, 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 and that number is 0. So to figure this out, you want to think about, if I set these denominators equal to 0, what value would I get if I tried solving for x? So here's what I mean. So the first denominator would just have an x. So the one number that x cannot be because of that denominator is 0. So x cannot be 0. 5, of course, is a constant, so we don't need to worry about that. 2x, if we put in 0 again for x, we would also get that x cannot equals 0. So the only restriction on the variable or on the domain here is that x cannot equal 0. And we'll do another example so you'll kind of get the pattern in a minute. Let's go ahead and clear the fractions though. So the least common multiple, so you want to think about what is a number or an expression that will cancel out or divide out all of these denominators. So for the constants, we've got a 5 and a 2, so the least common multiple there would be 10. And then we've got to get rid of the x's as well. So I'm going to multiply everything up there by 10x this time. That'll take care of all the denominators so that I can clear the fractions. So I'm going to multiply 10x times that first expression, 10x times that second expression, and then 10x times that third expression. So in the first expression, the x's will divide out. So I'm left with 10 times 1, which gives me 10. In the second expression, the 5 divides out and leaves me with a 2 and the x that's there in the numerator. So 2x times 1 gives me 2x. In the last expression, the x's, of course, will cancel out. 2 will divide out into 10 and leave me with a 5. So that means I'm left with 5 times 3, which gives me 15. And now we just solve it like a normal equation. So I'm going to subtract 15 from both sides. I have negative 5 is equal to 2x. And then we're going to divide both sides by 2. And then I get a solution of x equals negative 5 over 2, or 5/2. And notice that that was not our restriction. Our only restriction was that x could not be 0. If you happen to get a solution that turned out to be one of your restrictions from the beginning of the problem, you throw it out. We'll see an example like that in a few minutes. Let's take a look at example 4. So we have another rational equation to solve, and the equation we have is 10 over x squared minus 2x plus 4 over x equals 5 over x minus 2. So before we get too far into the problem, we want to look for restrictions by looking at where our denominators would equal 0. You notice that first denominator, x squared minus 2x, will factor. You always want to factor the denominators before you get too far into the problem. So x squared minus 2x factors into x times x minus 2, if you take x out as a GCF. And then let me rewrite the rest of the problem. And then what we want to think about is what numbers for x would make those denominators equal to 0. Start with the first first denominator, it's the most complicated one up there. If we set this equal to 0, we would have two possible values for x that would make this a 0. If we set x equal to 0 from that first factor, and if we set x minus 2 equal to 0, if x is positive 2, that would make the second factor equal to 0. So we're going to have two restrictions here because the other denominators are the same two factors, x and x minus 2. So our restrictions that we need to watch out for are that x cannot equal 0 and x cannot equal 2. Now we need to go through and we need to clear the fractions. So think about, with those three fractions, what your least common multiple or your least common denominator would be. So we need to have a factor to correspond with every factor that's up here. So we need to have an x and we need to have an x minus 2. If I go to the next fraction, I need to have an x, but that's taken care of from the first fraction. And then the third fraction, I need to have an x minus 2, but that's also taken care of from the first fraction. So I'm going to multiply everything up here by this x minus x, or x times x minus 2 expression. I'm going to come down here so I have a little more space. I'm going to rewrite the problem again. So we have 10 over x times x minus 2 plus 4 over x equals 5 over x minus 2. Remember, to clear the fractions, we want to multiply every fraction up there by this LCD term. So I'm going to multiply the first fraction by x times x minus 2, the second fraction by x times x minus 2, and then the third fraction by x times x minus 2. The reason we're allowed to do this is because we're doing it to everything on both sides of the equation. So in the first fraction, you notice this is like over 1. So you notice that this x times x minus 2 will cancel with the x times x minus 2 in the bottom. So that entire thing goes away, and I'm just left with 10. In the second fraction, the x's will cancel, but you notice that that leaves you with the x minus 2 term. So I have 4 times the x minus 2 term, and keep parentheses around that because we're going to have to distribute that 4 in just a minute. In the last fraction, notice that the x minus 2's go away, but I still have that x up there. So I'm left with 5 times x on the other side. And now we're going to solve it like a normal equation. So I'm going to distribute the 4. So I have 10 plus 4x minus 8 equals 5x. And then we're going to combine like terms. So we have 4x plus 2, 10 and negative 8 equals 5x. Then we need to get the x's on one side. So I'm going to go ahead and move the 4x over to the right side so the 2 can stay where it is, and I'll have the x's together on the right side. So I have 5x take away 4x, leaves me with 1x, or just x on the right side, and I have a 2 on the left side. So the solution I get is x equals 2. Now, remember we talked about those restrictions earlier. Do you notice there's a problem here? X equals 2 was one of our restrictions. So if that happens and you get something, you get a solution that turns out to be one of your restrictions, you're going to throw it out. Since we didn't have any other solutions here, 2 was the only one we got, that means we're going to have no solution to this problem because the only solution we ended up with happened to be one of our restrictions. So we're going to throw that solution out. Okay, let's go ahead and take a look at example 5. So they're asking us to solve another rational equation. So this time we have x over x minus 3 equals 3 over x minus 3 plus 9. So when I'm working with an equation where I've got fractions like this, I like to keep everything lined up. So I'm going to go ahead and put a 1 underneath that 9. Let's look at restrictions first. So the denominators, we're going to take a look at those. We have a denominator of x minus 3 and x minus 3, and of course a constant doesn't matter. So what is the one value if I considered where would x minus 3 equal 0? That would occur if x were equal to 3. So our only restriction this time is going to be that x cannot be 3. My least common multiple needs to be a combination of all my denominators. Well, this isn't too bad. My denominators are x minus 3, and 1. So if I multiply everything by x minus 3, that should clear the fractions for me. So I'm going to multiply the first fraction by x minus 3, the second fraction by x minus 3, and the third fraction by x minus 3. So in the first fraction, the x minus 3's go away, and I'm just left with the x that was in the numerator. The second fraction, the x minus 3's go away again, and I'm just left with 3. The third fraction, it's obviously the x minus 3 doesn't go away, but it doesn't matter because there's a 1 in the denominator anyway. But I do need to be sure to distribute that 9, so I'm going to put x minus 3 in parentheses. So let's go ahead and solve this equation by distributing the 9. So we're going to end up with 9x minus 27. If we have any like terms, of course, let's take care of those. So negative 27 and 3 gives me negative 24 plus that 9x. I'm going to subtract the 9x to go with the x on the other side. So we end up with negative 8x equals negative 24. And then we need to solve for x, so I'm going to divide both sides by negative 8. And that leaves me with a value of x equals 3. Now, you may notice a problem here. That was our restriction. So since our restriction was that x could not be 3, and the solution we happened to get, we only got one solution, and it happened to be 3, what that means is we're going to throw that out, and our answer is going to be no solution. And remember, that was because the solution we happened to get was one of our restrictions. And so we can't have a solution that makes our denominator equal to 0. So we're going to get rid of that. Okay, let's take a look at example 6. All right, so we have the expression negative 4 over z minus 7 equals 9 over 10. So first, let's consider any restrictions. The variable this time is z. Z minus 7, what would make that denominator a 0? Let me go ahead and write this down. And hopefully you see by now that if I were to set that equal to 0, I'd get a solution of 7. So my only restriction is that z cannot be 7. If I happen to get that as an answer, I'm going to throw it out. We want to go ahead and clear the fractions. So the combination of my denominators would be z minus 7 and 10. So I'm going to go ahead and multiply everything. Let me write this down. My least common multiple this time is 10 and the z minus 7. So I'm going to multiply everything up there by that expression. Let me rewrite this so it's a little bit neater. So I've got negative 4 over z minus 7 equals 9 over 10. So we're going to multiply the left side by 10 times z minus 7. We're going to multiply the right side by 10 times z minus 7. And so on the left side, those z minus 7s cancel out. So I'm left with 10 times negative 4, which is negative 40. The right side, the 10s cancel out. So I'm left with 9 times the z minus 7. So let's distribute that 9. So we have negative 40 equals 9z minus 63. And then I'm going to move the 63 to the left side. So I'm going to add 63. So I have negative 40 plus 63. Of course, that gives me 23. All right, and then I'm going to divide both sides by 9. And this time we happen to get a fraction as our answer. Not the prettiest answer, but that's okay. We get z equals 23 over 9. And notice that our restriction had been that z could not be 7. 23 over 9, of course, is not 7, so that's our answer. And then our last example, example 7, this is probably the most involved example we'll do, but it really does put together everything we've talked about in this lesson. So we've got 3 divided by x plus 6 plus 1 over x minus 2 equals 4 over x squared plus 4x minus 12. And if you can factor something in your denominators, you need to make sure you do that first before you start worrying about restrictions or least common multiples. And so hopefully you notice that that last expression will factor. It's a trinomial, so it'll factor into 2 binomials. So we're going to have an x and an x. We want numbers that multiply to negative 12 but add to 4. Often it's the combination of the other denominators we had in the problem. That's a common technique in these questions. So if that helps, you can look at those. But hopefully you see that it's positive 6 and negative 2. So I'm going to cross out the denominator and replace it with the factored version. So let's go ahead and do our restrictions next. So the restrictions, remember, are any values that would make any of the denominators equal to 0. So for the x plus 6, if you set that equal to 0, you'd get a restriction of negative 6. For the x minus 2, if you set that equal to 0, you'd get a restriction of x can't equal 2. And then lastly, if we set each of those equal to 0, we would get restrictions of negative 6 and 2. So I don't have to do anything else with those. I've already taken care of them. So my restrictions are negative 6 and 2. Now, as far as the least common multiple, it needs to be a combination of all these denominators. So we know we need to have x plus 6. We know we need to have x minus 2. And then I need to have something to take care of this, which is a combination of x plus 6 and x minus 2. So I'm taking care of that with these two expressions. So I'm going to multiply everything up there by x plus 6. Here's where it can get really messy if you don't write neatly, so leave yourself plenty of room when you write these. Like I said, I like to write that least common multiple that I'm multiplying everything by in front of all the terms that I have up there. So I'm going to rewrite, and I'm going to leave myself plenty of space to do this. So let's see. So we get 4 over x plus 6 times x minus 2. So I'm multiplying everything up there by that least common multiple. So over here, we have x plus 6 times x minus 2. The next term, we have x plus 6 times x minus 2. And then the last term, we have x plus 6 times x minus 2. So in the first expression, the x plus 6's divide out. So I'm left with 3 times the x minus 2. The second expression, the x minus 2's divide out, and I'm left with x plus 6 times 1. The last expression, everything divides out. That's nice, so we're just left with 4. So I'm going to distribute the 3, so we have 3x minus 6 plus the x plus 6 equals 4. 3x plus x gives us 4x. Negative 6 and positive 6, those go away, so that works out nicely. Equals 4. Divide by 4, and we get a solution of x equals 1. Notice that that was not one of our restrictions. If you'll recall, the restrictions were negative 6 and 2. We got a solution of 1, so we're good to go. That's our solution.